Here there is no friction between B and ground, and mu is equal to 2 by 3 between A and B. Okay. So let's see what's the work done here. Okay. So first we'll calculate the friction acting on A block. So the maximum friction which will be acting towards right. So that will be like mu mg, and mu is given mu 2 by 3. So it is 2 by 3 mg. Now we'll calculate the maximum acceleration of this M block. The maximum acceleration will be 2 by 3g. Right. Now here we'll follow that certain approach. So here we'll assume that both the blocks are moving together just to find the maximum value of the force. So if they are moving together, so that mass is 3m. So 3m, and the maximum acceleration with which they can move together, which is 2 by 3g. So which is coming as 2 mg. So up to this force, so that is the maximum force basically. Now up to this force they will move together, but the force acting is mg, so that's why they are moving together. So here we can conclude one thing: the blocks are moving together. Blocks are, so this one is greater than applied force, moving together. Okay. So now first we'll find the common acceleration. The acceleration of the system, the applied force is mg, and the mass is 3m. So acceleration of the system is 3 by 3. Now both the blocks are moving with the same acceleration. Okay, and that if they are moving together, which means the static friction is acting. And there's no relative motion. So if we see the first option, the net work done on block A with respect to B is 0, so that is correct. There is no movement with respect to A, right? So there is no force, there is no work done basically, there is no displacement. So first option is correct. Now we see the second option, net work done on block A with respect to ground for displacement. So with respect to ground, we'll see that force acting on A block. So on A block the static friction is acting, and the static friction will be equal to the external, that net force acting on it, and that is m mass into acceleration g by 3. So that is acceleration, that is the force acting on this A block, and with this force, that work done will be force into displacement. Displacement is s, so work done will be mg by 3 into s. So that is the work done on block A with respect to ground, so that B option is also correct. And C option, for that we need to calculate the work done on B block. So if you see the B block, and if you draw the FBD, so there's the mg force, and there's the friction, the reaction of this one, right? So which is mg by 3. The net force is 2 mg by 3. So the work done on this block will be 2 mg by 3. That is the force into displacement, right? So that C option is also correct. And the final, the work done by friction with respect to ground on A and B is equal and opposite sign. Yes, correct. Means the friction on A block is towards right, friction on B block is towards left, and the displacement is same, okay, because they are moving together. So the work done by friction on A block will be equal and opposite to work done by friction on B block. So fourth option is also correct. So that's it, all the options are correct, A, B, C, D. That's